All right, we're going to start off this new lesson today, this new unit, with a super simple question. What number times itself equals 25? Well, I hope you're able to just jump on that question. I hope you already know the answer. It's 5. Okay, if we do 5 times itself, that gives us 25. And, there's a couple other ways that you can express this fact. You could always say that 5 squared is equal to 25. That's another way of expressing that fact. And you could also kind of think of it backwards. You could also say the square root of 25 is equal to 5. These are kind of 3 different ways to express this same fact. Now I'm going to have you try this little activity. I'm going to have you try the same thing with these numbers. What number times itself gives you 225 or 900 or 0.81? Go ahead and hit the pause button at this time. Try these out. Just on a scrap sheet of paper, see how many of these you can get. Go ahead and hit pause right now. And let's see how you did. I think some of these were pretty straightforward. 15 times 15 is 225. 30 times 30 is 900. Here you get a decimal, 0.9. If you do 0.9 times 0.9, 0.81. Now here with the fraction, I'm kind of lucky. I have a fraction calculator. If I do the square root of 1 fraction 4, 1/4, it comes out in my calculator as a fraction 1/2. Although you could also have written it as a decimal, 0.5. That works as well. So all those are pretty smooth sailing until we get to here. What number times itself equals 5? Well, this is not so easy. We know 2 times 2 is 4. 3 times 3 is 9. So it's got to be some decimal in between 2 and 3. Here I'm trying 2.5. That doesn't work. That's getting me a little bit closer. Here I'm just trying to guess and check the answer. Oh, that's pretty close. 2.25. Try 2.24. Okay, even closer still. The reality is, so it's going to be some decimal right around 2.23 or 2.24. Let's try going backwards. Let's try taking the square root of 5. And interesting, I get this number 2.236067978. And your calculator shows all these decimal places, but in reality, this decimal never ends. When I write this, I have to put a ... after it to show this decimal actually never ends in reality. These decimals kind of are scattered around. They don't have any pattern, and they would continue forever. If I had a larger calculator screen, I could write this out to 1 billion decimal places, and it still wouldn't come to an end. So what are we going to write here? So sometimes students will just round and maybe say well, it's approximately 2.236. But watch what happens in my calculator. If I round it to 2.236 times itself, well, it doesn't come out perfectly to 5. So your options here, we're either going to have to round and have kind of an imperfect answer here, or a lot of times what we'll do is we'll just leave it in a square root sign. We'll say the answer is the square root of 5 times the square root of 5. Watch what happens in my calculator if I do this. The square root of 5 times the square root of 5. Now this will come out perfectly. Comes out to 5. So we'll touch base on what kind of number this is here. This is a very bizarre, imperfect number, and it all comes from this simple question: what number times itself equals 5? Now, likewise, the last one also it looks simple enough, but it's really challenging. Okay, we try doing, of course, 3 times 3 would give us a positive 9, so that's not the right answer. Negative 3 times negative 3, well, remember, a negative times a negative equals a positive. That also gives us positive 9, so that's not the answer. And yeah, you could try to cheat and put a negative in one box and a positive in the other, but that's cheating. That's not using the same number twice, okay? And our calculator is no help either. If we try to take the square root of negative 9 in our calculator, it gives us an error. It can't even answer it. Well, I'm here to tell you the answer is called 3i. Okay, And we'll talk more about this. We'll talk more about this in a later assignment. I believe it's assignment 3.4. But for now, just know, anytime you try to take the square root of a negative number, it comes out as what's called an imaginary answer. We would take the square root of 9, which is 3, but then because of this negative sign, we'd put an I on the end of it. And here's what you need to know about I. 3i times 3i is equal to negative 9. I is the only number in the world you can multiply by itself and get a negative answer. Okay? All right, so now that we've kind of answered all these questions, now let's classify the above answers into 3 main groups. The whole goal of today's lesson was to be able to classify numbers. Well, let's start with all the problems that came out very simply. And we got plain, simple answers too. These are called the rational numbers. Okay? And going down to our list here, the rational numbers, the technical definition, these are numbers that can be written as, and actually I'm going to change that real quick. This is numbers that can be made by dividing two integers. And here's kind of the little subgroups that this breaks down to. This means that any integer, okay, so basically any of your whole numbers, whether they be negative whole numbers or positive whole numbers, these are called rational numbers. These are your simple fractions. Simple fractions just means any fraction that can be made using an integer. So any fraction like 1/3, 5/4, even mixed numbers like -3 and 1/2. These are called simple fractions, fractions made from integers. These are all called rational numbers. And then there's certain decimals. Every fraction that can be written can come out as a particular type of decimal. They're either going to be terminating decimals, like 5/4 as a decimal is 1.25, and that decimal comes to a very distinct end. -3/2 is -3.5. That's called a terminating decimal. It comes to an end. But then there's also another category called repeating decimals. A fraction like 1/3 comes out to a repeating decimal, 0.3333 ... This is a decimal that never ends. It continues on forever, but it has a very distinct pattern. A repeating decimal can also be written using a repeating bar like this. So take all these together. These are called the rational numbers. Okay. Now the next category, this category right here of a decimal that has no pattern and it never ends, these are called the irrational numbers. Okay, and let's scroll down here. Let me scroll down here and give you a definition for irrational numbers. So irrational numbers are real numbers that cannot be made by dividing two integers. And we know them as kind of scattered decimals with no end. So see, an answer like the square root of 5, it's impossible to write this as a fraction. There is no way you can write this and say, oh, well, that's, 5 divided by 2 or 7/3. You just can't write this as a fraction. And then in decimal form, they have this scattered, they don't have any pattern. There's these scattery numbers that go on forever. So another example would be like the square root of 2. It comes out the same way. And really, any square root that's not perfect is going to come out irrational. Now, if a square root does come out perfectly, like the square root of 64 comes out perfectly, it equals 8. That would be considered rational because it comes out perfectly. But any square root that comes out imperfectly is known as irrational. There's also one more kind of famous irrational number I wanted to point out here, and that's pi. In geometry, you learn about this ratio pi, and it's approximately 3.14. I believe it's 3.14159 approximately, ... Those decimals go on forever. Pi is this irrational number. You cannot write pi as a simple fraction. Okay, so those are the irrational numbers. Now together, if you put the rational numbers and the irrational numbers together, these form what are called the real numbers. So real numbers are always going to be either rational or irrational. They're going to be one or the other. So every rational number is real, every irrational number is real. Okay, but the real numbers can be either rational or irrational. Now, if a number is not real, what is it called? That leads us to our last category called imaginary numbers. And imaginary numbers, these are the numbers that you get anytime you try to take the square root or an even root of a negative number. You get these imaginary numbers. So let's put that in our notes here. Imaginary numbers, the square root or any even root of a negative number, such as the square root of negative 9 equals 3i. The square root of negative 100 equals 10i. You get the idea. Now you can even have an imaginary number that has like an irrational in it. So like the square root of negative 5, you could write as radical 5 times I is kind of how you could write this. Imaginary numbers can be written as any real number times I is essentially how you can write that. Okay, so there's all of your definitions. You can see examples of each type of category of number. So you should be in good shape on this assignment. As always, message me if you have any questions. Bye.